To graph a shifted cosecant or secant function, we will just graph the corresponding sine or cosine, and then we'll use that as our template to create our asymptotes and then the branches of our cosecant or secant function. Let's go ahead and jump right in here. So what we're going to do is we're going to look at the corresponding, this is cosecant, which is the reciprocal of sine. So corresponding sine function, -2 sine of 3x plus pi plus 1. So we're going to start by just graphing this function, and then we'll work off of that. So we'll start with our key features. The amplitude of this is the absolute value of the number in front, which is absolute value of -2 or 2. Okay. We'll get the midline. The midline is y equals this number at the end, +1. We'll get the period. Period is 2 pi divided by the absolute value of b, which in this case is 3. So our period is 2 pi over 3. And then our phase shift is the x coordinate, or the x value that makes the inside here equal to 0. So you just set inside the function equal to 0, solve for x. We get x equals -pi over 3, so -pi. Okay, so we need to graph this function. I like to start with the midline. The midline, y equals 1. And then from the midline, go up and down the amplitude. So up 2 and down 2. And this kind of gives me my little box that I know how to stay in while I'm graphing the sine function. Okay, for sine, my starting point is going to be at my phase shift. I'm going to make each box here pi over 3. So this is -pi over 3, -2 pi over 3, -pi, okay, and so on. So at -pi over 3, I will be on the midline. For the sine function, at your phase shift, you will be on the midline. I know that my period, I'm going to end 2 pi over 3 later, so I move 2 pi over 3. That's going to give me an ending point of 1 cycle. For the sine, I know I have a point halfway between those. And then I need to decide between these, am I going to have a maximum or a minimum? So typically, with sine, we have a maximum between those first 2 points. But this negative right here will flip it, which means that we'll have a minimum down there. Okay, so it's going to flip down. We'll have a maximum over here between the second pair of points. And then we can draw. Now, I'm not going to draw this in black, actually, because we're not actually interested in sine. We're interested in the cosecant function. But I'm going to go ahead and do just a dashed. Okay, this is the sine function. I'm going to keep going because I want to see the full curve while I'm graphing the cosecant. Okay. Now to graph the cosecant, we look at this sine function that we drew, and everywhere that this sine function touches the midline, I will have a vertical asymptote. So I'm going to draw all of those vertical asymptotes. So that's going to be right here. And I see that it happens at every pi over 3. So we create those asymptotes, and then once we've got our asymptotes, we'll create the branches of the cosecant function the way we have in the past, and that's just simply flipping maxima to be minima and minima to be maxima, and then following those asymptotes. So, for example, here I've got this maximum. I'm going to have that point as a minimum now, and then it will flip and be a minimum. And down here I've got a minimum of the sine, so it'll be a maximum of the cosecant. And so we get each of these each of these branches from that sine function.